Welcome to today's webinar brought to you by Databricks and Blueprint. I'm Stephen Fig, Director of Database Trends and Applications and Unisphere Research. I will be your host for today's broadcast. Our presentation today is titled Achieving Unified Governance for Data and AI, Unity Catalog Migration Simplified. Before we begin, I want to explain how you can be a part of this broadcast. There will be a question and answer session. If you have a question during the presentation, just type it into the question box provided and click on the submit button. We're going to try to get to as many questions as possible later. Plus, all viewers today will be entered for a chance to win a $100 Amazon gift card just for participating. Now, to introduce our speakers for today, we're very excited to have with us Michael Halleck, Director of Product Sales at Blueprint, Shannon Lauder, Solution Architect at Blueprint, and Ketan Ganatra, Solution Architect at Databricks. Now I'm going to pass the event over to Ketan to get us started. Welcome to the broadcast, Ketan.
All right. Thank you. And thanks, audience, for spending time with us today. Today's session, we are going to start with a brief introduction to Databricks. I realize that most of you are already familiar with it, or in fact, maybe even working with Databricks very closely. So I'll keep it brief. And let's go to the next slide. Can you see the slide?
Yes.
Okay, I wanted the democratizing slide to be up. Is it the one that's up?
That's currently up right now.
Yeah, okay. All right. So at Databricks, our mission is democratizing data and AI, and that's our mission for ever since the company has existed for 11 years. My name is Ketan Ganatra, and I am a solution architect at Databricks. And so, who is Databricks? We are, as I mentioned, we are a 10 years old company. We have 10,000 plus customers globally distributed. Our revenue stream is at this point 1.6 billion. We have more than 4 billion in investment from a lot of high-profile investors, including all three clouds and some big-name venture capital firm from Silicon Valley. Databricks is the inventor of Lakehouse paradigm. You hear that name a lot. That's the concept that we invented, and we democratized that concept. Lakehouse is essentially a combination of your traditional data lake and data warehouse combined fused into one product. So that's Lakehouse. We are also pioneers of generative AI craze that's going on right now. We had been active in generative AI long before ChatGPT came out and it became a thing. So we have top researchers in our company that have been working with generative AI for quite some time. We have a fair share of our industry recognition. If you look at the bottom segment, bottom right, bottom center, Gartner has awarded us the leader designation in not one but two categories: database management system, that's your traditional, you can say, data warehouse type of applications. But we are also a leader in the top right quadrant of Gartner in data science and machine learning platform. And as a matter of fact, something that just came out today, Forrester is another analyst firm. They've started tracking generative AI leaders. And as of today, the Databricks has been placed in the leader quadrant by Forrester as well in generative AI industry segment. On the right, you see some of the open source project that we have invented and shared with the industry. And that's the area, that's the part of Databricks that I'm most proud of. Delta Lake is our cloud data storage format. MLflow is the software package that helps you track the entire life cycle of machine learning experiments and productionizing your ML artifacts. Apache Spark is the big data processing framework for large volumes of data. And DBRX is the state-of-the-art large language model, kind of like Llama 2, Llama 3, and others in that category that you see. We built this model, large language model, and last month we open sourced it for anybody to take away. So that was Databricks as a company. And now Databricks as a product. Our product also goes by the same name. The full name of it is Databricks Data Intelligence Platform. And here on screen, I have a high-level architecture of what the platform is all about and what it can do. So Databricks is multi-cloud. We sit on top of all three cloud: AWS, Azure, GCP. We use their storage, and we use their some of the basic compute and basic networking. And our platform runs on all three platforms. So you will have the same capabilities and similar user experience no matter which cloud you go to. So that's one of our differentiator. On the top line, if you see, these are sort of our product lines within the platform. We have a full stack AI, machine learning and AI capabilities, which we label as Mosaic AI. ETL and real-time analytics, this is bulk of our workload, sort of like bread and butter. And the important product capability to note is Delta Live Table. We have workload orchestration capabilities in the form of Databricks workflows. And we also have traditional data warehousing, top-notch capabilities, highly performant, highly cost-efficient. And that product is called Databricks SQL. And all of this is available under one roof on one platform, no matter what your use case is, no matter what you personalize. It's all available as soon as you log into Databricks. All of this is available to you. But the middle layer, if you see Unity Catalog, that's really what we are here to talk about. Unity Catalog is a unified security, governance, and cataloging offering. So, what is big deal about Unity Catalog? Why it is important for us to take a look at Unity Catalog before we even talk about migration? What is Unity Catalog, right? So, if you see a typical enterprise landscape, data is critical, right? Everybody, you might have heard the phrases: "Data is the new electricity," "Data is the new oil," and stuff like that, right? So, everybody agrees. But if you take a look at it, data comes to you at a very fast pace from various different sources in many different shapes and sizes. Your data can be structured, unstructured, semi-structured. Your data can be coming at you in the batch format or streaming format or real-time or semi-real-time format, right? And all of that is coming at you fast. And they might be destined to a data lake or a data warehouse, or it might be feeding machine learning models or data science experiments, or it could be consumed by your BI applications. And there could be various different roles within your organization that might be contributing to the data assets or consuming the data assets, right? You could have data analysts in various business lines of businesses. You could have data engineers, machine learning engineers, data scientists, your automated applications hitting your data assets all at the same time. Now, if you put together all these possibilities, right? Various different types of data residing at various different places, being used by various different persona, and that just gets insanely complex, right? It becomes like a massive spaghetti diagram. And that really presents a challenge about governing the data and making sense out of the data and making that data available to the folks who need it. So, here's some quote from the industry highlighting the value of data, which again, we all agree it's valuable. But remember this, data is valuable only if right data is made available to the right people at the right time in the right format. Otherwise, it's garbage. Just imagine your application being fed a previous version of data, or data getting in the wrong hands where they should not be seeing, or even worse, when you need it, the data not being available to you, right? If your application depends on certain data set and suddenly it doesn't become available, it becomes unavailable to you, right? All these scenarios will drag away the value of data from your organization. So these are some of the key things that you need to be looking out for. Data and AI governance is complex. Why? Because your data is sitting in many different places. It's very fragmented. You could the tools that you use to govern a data asset. There are multiple different tools. For structured data sets, you have one ECL. For file systems, you have another ECL. For your machine learning models, for your streaming data sets, you could all be potentially dealing with different tools and different procedures to control your data, and that becomes a nightmare very soon. You might be missing the capabilities to observe and monitor your data sets, right? Because once the data enters your platform, that's not end of the story. It's just the beginning of the story. The data will continue to evolve. The data will continue to flow across the landscape, and somebody needs to be watching it and say, hey, the data quality is degrading. Can we just stop it and look inside the hood as to what's causing this corruption? Or who are your constituents that are consuming certain data sets? So if you want to make a change, you can assess the impact, right? So monitoring and observability is important, but it's not available out of the box in many cases. And let's say you have all your data covered, all the pieces are working together on your platform nicely. But what about being able to share it externally? If your supplier needs a data set that you are working on, how can you share it in a quick and effective and cost efficient way? And if your supplier has a data set, how can you bring it onto your platform in a safe and cost effective way? Right? So these are some of the things that will affect the value of data in your organization. And that's where Unity Catalog comes in. Unity Catalog brings you answer to a lot of these questions, right? So in the box, if you see the components of Unity Catalog, what does Unity Catalog as a product consist of? So Unity Catalog brings on the table discovery, which is there's a unified search box, and if you just type, even in plain English, what you're looking for, you will get a scan across your platform, and it will produce a list of all your data sets, all your file systems, all your machine learning models, all your BI applications, BI dashboards, your delta shares, your marketplace assets. All of that will be pulled together in one. Access control, there's one single plane of control where you can define the permissions at individual level, at principal level, at group level, to control all your data assets in one. Lineage is where you are able to trace the journey of data right from the point it enters the data to how it gets transformed, where it gets stored, what applications, including machine learning models or your BI applications, where does it get fed, and who are consuming your applications. You will see it in the form, a visual format, the entire journey of your data assets. And then it also allows data sharing, auditing, and monitoring capabilities. And when you include Unity Catalog in your application stack, in your solution stack, in your architecture, the roadblocks that we previously saw are not so difficult anymore. They are easily solvable with the help of Unity Catalog. And I have some slides here. I'm not gonna go into the detail. The slide deck will be available to you. You can browse it offline. If you have any more question about Databricks in general or Unity Catalog, feel free to visit our documentation or reach out to me. My email will be also provided. So we all agree, we established that Unity Catalog is important. It is somewhat effort, somewhat resource intensive to activate Unity Catalog in your organization. And so that is where the role of an expert like Blueprint comes into play. They have the experience and the tools and the techniques to help you get there and get you started on using Unity Catalog, not only putting it the right way, but getting you off and running to start consuming your data sets the right way. So for that bit, I would invite Shannon to walk us through your migration capabilities for Unity Catalog. Shannon?
Awesome. Appreciate it. So usually at this point, we will get the question, well, how does Unity Catalog help us optimize our lakehouse? Really, Keaton did a great job explaining. You get that single pane of glass where you can see all of the information about the data that exists in your lakehouse. You can see who has access to it, what notebooks, what dashboards, what's consuming the data, who's consuming it, how often is it consumed. that single place to go whenever you have a question about your data, I can't overestimate the value of having that single pane of glass. Unity Catalog also allows you to spot and eliminate duplicate or redundant data or compute. So if you're in a traditional dev shop, you've got a dev, a test, and a prod environment. And a lot of times that means 3 copies of the data or 3 subsets of the same data. Well, once you've enabled Unity Catalog, you can set up multiple catalogs for the same information, one for each of your environments. And you can also use something like shallow clone, to where instead of having to fully duplicate the data, you're using pointers and you're actually sharing data between these different environments. And it does so in a way that reduces the cost while maximizing the abilities in the platform. And it's not just the data storage that you can eliminate. Once you see Unity Catalog come online and you start looking at the lineage information, you can spot workloads that are duplicate of each other. You can see that, say 5 different notebooks are actually reading the same data and all are producing nearly identical transformations of that data. Well, instead of storing it and computing it 5 different times, why don't we share that among consumers? So once you've gone into Unity Catalog, you can start making this kind of optimization. And finally, Keaton did a great job talking about, how easy it is to manage who has access to what, whether they're inside your org or outside your org. That single pane of glass lets you control access to your data in very granular ways. So these are all the reasons that we usually encourage our customers to adopt Unity Catalog. And now, how do we actually get you there? So it's going to look really simple, but it's just a 3-step process. We go in there first into your environment and we run an assessment. We want to look at what do you have in your Hive Metastore. We want to look at your notebooks, your SQL queries, your dashboards. We want to look at your clusters, pipelines. We want to look at models, experiments that you're running. And the reason we want all this information is enabling those features to use Unity Catalog and be accessible through Unity Catalog means you're going to have to decide on a configuration. For example, if you've got data stored to DBFS root, well, to move forward, you need to move that into some sort of cloud storage, some sort of external storage. So you can set that configuration with us. And we collect this configuration in a way so that our scripts, our execute step, reads this configuration information and it runs the same type of data movements and data transformations in a repeatable way. By following that configuration, we can reach any desired state that you'd like in Unity Catalog. So sounds like a pretty easy process, 3 steps. There's a lot of hidden details that when we engage with you, we will work through that complexity with you and help you ease into Unity Catalog. So let's go to the next slide and let's look at assessment results. So this is an example that we ran in one of our clients. If you're familiar with the Databricks UCX open source project, it provides very similar functionality. We both started in the same place, but over time we've gone ahead in a few places to make it easier to run the execute step. So on screen right now, you're seeing an example of a Hive Metastore. You'll see we found almost 9,000 objects. So these are tables, views. You can see that 6,200 of them are managed tables. So those are stored most of the time in DBFS root when we're talking about Hive Metastore, but some could be external. And then we've got 1,100 external tables. These are usually stored on that cloud storage we're talking about. So migration is pretty simple. And you'll notice that there's 1,500 that we need to look at to consider how do we want to configure that. So this can be things like you're storing CSV or JSON data as an external table. How do you want to migrate that? This can be, again, DBFS root data. How do you want to move that? But these are the tables that you're going to have to absolutely come up with a configuration for in order to move into Unity Catalog. Over in the upper right, you can see we found 25,000 items. These are workspace items. So think of everything you have under your workspace folder in Databricks. These are your notebooks, your Pi files, your Scala files, your dashboards, even your repos. The reason we assess this is we want to find, will there be any impacts if we were to move a given data object from Hive Metastore into a Unity catalog? And the answer is yes, there's almost certainly an interaction, but we need to discover, well, how complex is that interaction? And this is our first measure of how we discover that. Then if you look in the next box down, you can see of the 8,995 tables, you can see 7,800 of them are actively being used. We actually dig through your queries and the actual run, the execution of your own code in your environment. And we want to see how many of these objects in Hive Metastore are actually being used on a regular basis. How many of them are possibly orphaned? So this active footprint really delves into that and gives us a better picture of your current state. And not to dig into this too much, but you can see we assess your jobs, grants. So anytime you've run a grant permission on an object, we collect that. Your list of databases, your list of groups, Hive functions, your clusters, DLT, it's all here. And in fact, we will reveal during the assessment phase some recommendations, some next steps before we move into that configuration step. And that's, once we're through the configuration step, we move straight into execution and we start enabling you in Unity Catalog. And that's our accelerator in a nutshell. At this point, I'd like to pass it over to Michael so that he can walk you through some other ways that you can optimize your Lakehouse experience.
Awesome. Thanks, Shannon. I'm going to go ahead and switch gears from doing the PowerPoint presentation to doing a live demo. One of our agile principles is to demo working software, so we're going to jump into that. Let's go ahead and get the screen share fired up here. All right, so assuming that is coming through now, what Shannon just finished showing us was actually this first tab up here, the Unity Catalog Migration module, which is part of our Lakehouse Optimizer product. And I'll take a step back a little bit and just talk a little bit more about who Blueprint is and how this tool came to be before we start digging into some of the features, functionality, and some of the details that might be relevant for folks as well. Blueprint, we're kind of a unique partner for Databricks. We're both an SI partner, so we help people accelerate their journey on the Lakehouse of some traditional means with projects and teams dedicated to help folks out move their journey forward. But we're also a ISV partner. So we have a number of tools and accelerators that we produce to further that mission and to make sure that more folks can have unfettered access to these capabilities, independent of their ability to be able to engage with us from a project or team-based approach. So the Lakehouse Optimizer is something that was created initially because a lot of organizations were having trouble identifying what they need to do in order to get the most out of the platform from a cost and performance perspective. Over time as well, Blueprint, we have a really keen focus on data and AI governance. And we had some accelerators like Shannon was describing that were helping folks move over to Unity Catalog. And when we did one of our larger migrations with a large enterprise, we found some incredible cost savings that came from, like Shannon was mentioning, the reduction in compute and reduction in redundant storage. And so being able to score those results and be able to tie that effort back is one of the reasons why we integrated those two components together for the Lakehouse Optimizer or LHO product as a whole. And so as you can see now, you can dive in to understand your assessment and the requirements for you to be able to move over to Unity Catalog. And then the remainder of the platform, of course, will help make sure that you're getting the most out of that investment as you move forward and accelerate your journey into leveraging the Lakehouse for more and for more use cases. I happen to be demoing this out of a Azure environment example. We also have an AWS version as well. So for AWS folks, I apologize if I'm referring to some Azure cloud primitives, but we do have the same level of functionality on the AWS side as well. One of the first questions that we typically get from folks is to understand what their total Lakehouse spend actually looks like from both Databricks and their cloud provider. So moving forward with that same viewpoint of wanting to have everything in a single pane of glass. We provide that here at a high level, but then we also demonstrate that at a very granular level, even down to individual tasks that are run in a specific notebook and things like that. We also have the ability here, if we look at the right-hand side, to bring in all of the various tags that might be configured over in Databricks as well. This is another thing when folks are moving into Unity Catalog that they should consider. Use tagging as much as possible. It'll help ensure that with that consolidation, you're leveraging tags to be able to do things like chargebacks or attribution of usage and things like that. And Lakehouse Optimizer will read that information in and be able to distribute that. Like, for example, we have business units here over at Blueprint, and I can see how our solution delivery part of the organization, for instance, is leveraging our Databricks environment, the executive leadership team, the product team, and some others. So some great capabilities there, and we can drill into underlying workloads, not only just for those business units, but even for different specific use cases or IT projects or business processes, however you want to abstractly tag and group your business. We can report that out here and give insights for each. Things start to get really interesting when you move into this optimization health category, where we show an overall aggregate amount of healthy spend and have that broken down between 3 categories of efficiency, performance, and orchestration. So the Lakehouse Optimizer is running in near real time adjacent to your Databricks environment, and it's collecting telemetry and metrics about all of the interactions that are happening on the platform and generating recommendations based off of incidents, and also sending out alerts as well, so that you can have a clear picture of what is important, where you need to take action, and how to ensure that your usage of the platform is, as we're describing here, overall healthy. So anytime we have a workload that gets tagged with something that needs to be modified or adjusted for an improvement, that'll be flagged here in that unhealthy spend category, so folks can go ahead and drill in and identify what some of those areas of concern actually are. A lot of these optimizations, pretty cool. They come as a result of migrating to Unity Catalog. And so the whole ecosystem is really benefited when you're making those updates, leveraging some of the latest and greatest Databricks capabilities, and then verifying that you're leveraging them as best as possible using the Lakehouse Optimizer. I'm going to scan through a couple more of these modules that you see here on the left. Of course, we're at this overall tenant view. We're going to look at workspaces, workloads, and incidents a little bit. And then, of course, make sure that we have some time towards the end to wrap up for questions. While I'm going through this, feel free to tee up questions in the chat. We'll love to make sure that those are being heard and understood. I'm going to go through this content fairly quickly. Usually I can talk for Lakehouse Optimizer for hours. I don't have a ton of time for that. So make sure that you jot anything down as you see something come across on the screen, and that way we'll make sure that we can answer that as we go through this material as well. Here in this workspaces view, there's a few additional deeper drill throughs that we'd like to highlight. We have the ability for folks to enter in their budget and their commit levels. They can do that from individual workspaces, or also see that aggregated all up. I'm looking at all of my Azure subscriptions currently, and I can quickly see at a glance which months I have Databricks usage that is in or over budget. I can also see what the projected cost looks like to make sure that things are staying within check. A lot of organizations love to use this in conjunction with their Databricks commitments. So that is a really easy way to be able to make sure that you get a great discount just by ensuring that you have the appropriate amount of Databricks commit. And organizations will use this to ensure that they have the most confidence in what that commitment level should be, so they can maximize what that discount footprint ought to be as well. Over here on the bottom right, we have this view that we describe as workspace stats. And so it's going to start to show a bunch of individual components for all of the different features that are being leveraged in the platform. So you can see in this view, I have job clusters, all-purpose compute, DLTs. We also have coverage for classic and serverless SQL warehouses, and pools and storage as well. And you can see at a glance how these things are trending and changing over time. Additionally, I can view any one of these items on an individual basis. So if I wanted to say, make some transitions from job clusters and all-purpose compute, and get a sense on how I'm migrating from one to the other, you can kind of get a sense that we decided, hey, we should start changing some of this all-purpose compute behavior to be scheduled on jobs. Spoiler alert, that's a great optimization to consider. If you have scheduled jobs running on all-purpose compute, changing over the job clusters will help you save some money and ensure that you have some dedicated performance for those. That's one of the types of incidents that will be flagged by Lakehouse Optimizer, brought to the forefront, and ensuring that you have the ability to take action on that. So you can see a little bit of traction over here. We've started to migrate some of that component over from all-purpose cluster to job cluster. So you can sort of choose your adventure and identify how that migration or those changes are actually happening over time. Up here on the top two, just to give one more note to round this out, you can see the comparison directly between the cloud cost as well as the Databricks cost. One of the most important things for this is to ensure that as you start to use some of the more modern Databricks SKUs, some of them, they leverage higher DBU burn. Like for instance, SQL Serverless as well as Photon will also use more DBU consumption. That said, there is a commensurate and significant drop in cloud consumption that's being used as well. So it's important to keep both eyes open when you're evaluating your architecture. And Lakehouse Optimizer will help you understand what that total balance actually looks like, so you can make the best decisions for your environment. And of course, once you're on Unity Catalog, there's a lot more options that are at your disposal to ensure that you can go ahead and do that. I'm going to click a couple more modalities of usage. We have a workloads tab, which will show some more coverage and some interesting stories in there. Incidents, like what we were describing, I'll show some examples of that contextually. Organizations will use this in two main approaches. You'll have folks in the center of excellence or in the managerial front that are going to be probably not in the interface on a daily basis. They're going to be waiting for those incidents to fire off an alert to ensure that they know where to look and how to triage some of those challenges. But then also practitioners will be in the workloads pane with their named workloads that they're working on, developing on a regular basis, or if they're specifically looking to optimize them by name, they'll be in this view with Databricks essentially on their second monitor, using Lakehouse Optimizer as their co-pilot to get the most out of the platform. Across the top, you'll see a number of different categories for the different compute types that we are monitoring and providing insights into. Obviously, we've landed on workflows right now. We also have this notion of jobs that you typically will create within Databricks. One-time runs, like if you use something like Fivetran or Azure Data Factory or one of those external services that will generate jobs. One-time runs tend to be orphaned from each other. They're hard to track within the Databricks platform. We centralize those here so that you can follow the full lineage of them and make sure that those are being orchestrated as best as they can. We also have coverage over things like all-purpose clusters, Delta Live tables, SQL warehouses, and pools, and I'll bring out a couple of examples of those as we dig into this a little bit more. In this main data table, we have a list of workloads, so no surprises there. Each one of these has each one of their individual job runs for each one of these workflows and a variety of rich telemetry to make sure that you're getting the most out of them. You can see the number of incidents that have been flagged. So, well, it looks like there's some great opportunity for optimization here, as well as what the total cost looks like. So we have this broken down between VMs as well as Databricks cost as well. So again, down to even a level of granularity, you can understand where the bill is going and where there's room for improvement as you go through and make optimization changes. I'm going to drill into this first one, Alpha Supply Chain Monitor. And from within here, you'll start to see some additional complexity that might be a challenge typically to be able to wade through, and how Lakehouse Optimizer will make it more simple and straightforward. Within each one of these, I have a couple of different job runs. You'll see there's two that are listed on this page. Each one of them has individual tasks as well that are running concurrently. Within here too, you can see now each one of these job runs, the number of incidents that occurred, the task name, the amount of data that was being processed per task, as well as the total duration for each start and end time, and then a number of additional metrics as well. We have things like managing data skew, disk spillage, overall utilization of CPU and memory resources as well. And just at a glance, this can start to give you some indication of where the heavy aspects are of a particular job, if there's room for reorchestration, and how to start making some improvements. So you can see, of course, this particular task here is where we entered in the most of our data. And then probably towards the end, we have a few more smaller lagging tasks where a little bit more data continues to stream in. You'll notice we have this large number of incidents, and this little badge with a heart is consistent with the icon you see over here. These incidents are, you can kind of get to both of them from either one of these locations. I'm starting at this particular view as opposed to going to the incidents aggregate. If we have some time, I'll take a look at that here in a moment as well. But let's start looking at some of these incidents to make a better sense of what LHO is telling us about how we can improve how this job actually runs. So there's some additional high-level information here. It shows the type of driver and workers that are being used. We have auto-scaling enabled, the specific instance types that are being run, as well as the instance rates. This is broken down between the VM cost as well as the DBU charges. And it will also show you if Photon is enabled, what the DBU burn would look like for that as well. In addition, some additional details about the size of those VMs, if it's compute optimized or if it's Photon capable as well. Down a little bit below, it'll show the incidents that were flagged as well as the recommendations that were generated. So we have a couple of incidents here, like we described, for performance and over provisioning. It shows that the cluster CPU is over provisioned. And as an aside, we find it really important to make sure that we're not just providing blind incidents or recommendations. We want to make sure that we're validating and substantiating the information that we're given so that our practitioners can make the best changes in the context of how this job actually works for their business. Of course, we can infer as much as we can from a telemetry perspective, but nothing beats the human level context that can be provided from the team. And so we want to ensure that those individuals are well equipped to make the best decision and then empowered to do that as well. Digging in a little further, we can see here more over provisioning on cluster memory as well as on driver memory. So it shows about 5% of the amount of memory is being used. We see up here about 24% of the cluster CPUs being leveraged. So generally, this is a great example and an opportunity where somebody provisioned this job and they ran it on too high of a set of resources than is actually needed to run it. So this allows us to then make some more prescriptive recommendations to make some improvements here. First, it's suggesting that we scale the cluster into 6 worker nodes. It looks like it's not taking advantage of the maximum amount of scaling that's available there. We had a couple of organizations that were running out of capacity for virtual machines in the cloud based on their amount of concurrent CPU usage. And so this is one of those areas that can help make sure that additional jobs have the capacity that they need just from a parallel processing perspective. Also, another recommendation here is to scale the driver node as well as the worker nodes down. It'll give you the change in rates as well as the amount of memory and core changes so that you can feel confident that this recommendation isn't going to negatively impact the SLA of any one of these jobs. I'm going to back out of this and show one more area that we can dig into as well. We can also see a very detailed and granular list of all of the different clusters that are being leveraged for this particular job. This one's interesting since we have so many different tasks that are running here. Some of them are probably healthy. Some of them have some room for improvement. You can see here that some of them are running on job clusters. We have some built-in tooltips and links out to robust documentation so that if you're a little bit new to Databricks and a lot of this is intimidating, just hover and follow the links and it will take you on a journey to figure out how you can improve that knowledge with the ability to ask the question for you, so to speak. You can also see one of the examples we described before. A couple of these tasks are running on all-purpose clusters. It'll give you some information on why that is an anti-pattern, and again, some documentation to link you out there. That way you can make some immediate improvements in that regard as you go through the stream. I'm going to dig into this particular level of this task, and this will now show what the total level of utilization is for, you can select any one of the various system metrics that you want to be able to see, and identify how well utilized the driver and the executors are. I have 2 executors that ran in the cadence of this job. We have this merge charts feature, which lets you actually overlay the utilization of each one of the executor nodes, which can be really beneficial. We find some scenarios where a couple of nodes are running really hot, and the way that the code is written demonstrates that the remainder of the nodes that are cold are just not getting data to process because they're not written in a manner that takes advantage of some Databricks' parallel compute opportunities. And so this is a great way to validate that as well. Additionally, this is a great opportunity to see whether or not you like the way that the recommendations work kind of in aggregate, and also to find out if there's some additional orchestration opportunities within each one of these jobs to see if there's varying behavior across the life cycle of the job so that you can, again, have the appropriate context and confidence that you make the best optimization decision that you can. I'm going to jump back out to workloads and show one more example over here in the pools area. So we have a number of pools that are running, and I've got a little bit of data from some different pool usage we were experimenting with in the past. So I'm just going to go grab a different date range here. And we're going to box select on some of this hot spotted area of pool activity. So each one of these colors on the screen now represents an individual workload. And what's pretty interesting about this is if you've ever had a chance to use pools, pools are really beneficial. They allow you to have always-on resources that are available to minimize the SLA of the jobs that need to be executed. But they also are a bit of a double-edged sword. They can be left idle, and as a result, they can also drive up the cost in a wasted or inefficient manner, as we like to describe. We have alerts that will flag that kind of behavior to bring you into here as well. And then to be able to see exactly how these jobs worked, how auto-scaling occurred. You can see when this job grew in its vertical footprint, it grabbed a few additional virtual machines. Some additional jobs also started to be kicked off at the same time, and you can see how the pool's capacity is essentially filled up. What's also really interesting is this dark shaded area. So you can see here, this is a great opportunity for a auto-scaling anti-pattern. Sometimes when you have auto-scaling that's configured inappropriately, it can cause some challenges. So in this case, we have a very short auto-scaling event, which ended up having the amount of pool utilization spike to the top. And then as the job started to sunset, you can see all of the idle time that incurred. So LHO is analyzing this idle time and giving recommendations based off of that so that you can improve your orchestration. And then, for instance, these additional jobs that you see here that are getting fired off, it's a great opportunity to visualize how they can be drawn forward, orchestrated earlier, since you have available CPU capacity. That way things can get done more quickly, and you can leverage the amount of compute that you have available, and it's essentially a win-win. Additionally, if you have questions about any one of these individual workloads, we can drill in to them on an individual basis. And that kind of brings you back to that workload screen that we were looking at before. This one had a specific incident regarding data skew. If you've ever spent any time in the Spark UI, you probably had a little bit of pain there. That's just kind of the reality of the way that the Spark UI works. What this will do is it will essentially read the Spark UI out to you whenever there's actually something that's important to look at, and it will cache it too. So as soon as the resources are turned off, they're still made available. So you can still have these insights in an ongoing basis. Like this job ran in September and I still have these results cached by LHO. So it found here that we had a Spark task that executed for about 33 seconds. The average was 25. So that gives an indication that perhaps there is a issue with the way that data has been partitioned. We have some specific recommendations to help ensure that that doesn't occur as well. It's a great opportunity to also improve the speed and performance of this job and make sure that it runs in a more healthy pattern. Also, we can drill into these skew details. If the resources were still on, I can dive directly into the Spark UI if you wanted to paginate there on your own. But then this will also give you some of the specific Spark job groups. It'll help you understand how we computed this, again, giving you that context, not just giving you blind recommendations, but comparing average versus max duration, as well as average versus maximum amount of data that was being read at each one of those Spark job groups. If there's unsuccessful tasks as well, that can contribute, and we'll report on that here as well. Last thing I'm going to show is just a kind of a glance over to the incident side of things. So we were describing how we have a number of incidents that get flagged. Again, this takes away all of the guesswork. It helps you allow LHO to run this monitoring and analysis and make it really easy to know where to look when there are some challenges. We were looking at a number of scenarios and workflows. We have about 36 different incident types, just to give you kind of a sense of what some of those look like. Like if I wanted to find all of the jobs that had my cluster CPU over provisioned, I can go ahead and search for those. And then I'll have a list of each one with all of the details that were related to each. So then as a practitioner, I can look at daily marketing metrics. I can view the cluster configuration if I'm interested in making changes. I can open this in Databricks. I can also open the workload directly to be able to take action like we were looking at before. And then, of course, use this to verify exactly how things are working and where there's room to be able to make improvements. Another really interesting fact about this, and I'll kind of conclude the screen share component on this, is as it relates to getting things going on Unity Catalog, there's always a lot of questions about whether or not a workload should be run on serverless or in a classic warehouse. We have the ability to monitor and track those and to give you some recommendations on where the best places to run those are. Again, that's also enabled by Unity Catalog. If you're not on Unity Catalog yet, highly recommend taking advantage of getting this tool provisioned within your environment. It'll help you follow the path to get provisioned and to get up to a better, well-governed state using UC. And then for the duration of your journey in Databricks, it'll help you keep things optimized as you continue to move forward, growing usage of the platform and getting the most out of it. One more thing I was going to share too, just as a quick aside. Like we were describing, just from a call to action perspective, we do have a number of resources that you can take advantage of for free over here on our website, and you'll find a link to this at the end of this session. We have a Unity Catalog checklist. You can also sign up to have our Lakehouse Optimizer deployed for you as well. We're extending some of our promotion that we're firing off for the Data and AI Summit. So you can get a free assessment if you're one of the webinar attendees or if you're an attendee of Data and AI Summit. So if you or one of your colleagues wants to take advantage of that, feel free to reach out and contact us here as well. And we'd love to have you guys come visit us at the Data and AI Summit if you happen to be available in person. We're hosting an ideation lounge. Would love to talk to you about some of your business challenges, how Blueprint can help, and how you can get access to a number of our accelerators, which can help improve your livelihood on the Databricks platform. So these resources are made available to you folks. You can reach out to us. We have a number of other additional resources. Shannon just did an Ask Me Anything about Unity Catalog, which goes into some of the deeper details about that platform as a whole. And we have a number of resources as well that you can take advantage of there. So continue the conversation. Hope to see you folks at Data and AI, and looking forward to connecting there.
Okay, we're going to dive into questions from our viewers today. We had a number come in during your presentations. And Shannon, this first question I'm going to direct at you. The 3 steps to migration seem easy. What can complicate a migration to Unity Catalog?
The number one thing that complicates any migration is the code and the interaction between the code and the data objects themselves. If you're in an environment that's heavily invested in frameworks, metadata-driven frameworks or config-driven frameworks to ingest data or transform data, it's a lot easier to migrate that environment to Unity Catalog. You simply make a change to the framework to start supporting 3 namespace. It's straightforward. But then there are other environments that have a lot of bespoke code. Everything's a little bit of a one-off. It's not that you can't move those to Unity Catalog. It's just, it's not as straightforward. It's more complex.
Understood. Keaton, our next question is for you. How is Databricks different from other data platforms?
All right. Great question. So, data platforms is sort of like an essential backbone, essential commodity for all the enterprises. And oftentimes when they go shopping, they look at a number of different choices. There are cloud, native cloud service providers. There are some competitors that we have and Databricks. So there are a couple of differentiators, right? And I cannot speak to the other platforms, but what I hear our customers saying about Databricks, I'm just going to briefly share a couple of differentiators. So one of them is the big differentiator is that Databricks is built on top of open source community, open source systems. Take, for example, Spark, right? The Spark that is the crux of the whole platform. It's an open source product. If you want, you can go and download and host your own instance. But if you come to Databricks, we give you better, faster version with full management capabilities. But it is open source at the core. And same applies for MLflow, same applies for the Delta Lake storage format. So our commitment to open source community is one of the big differentiator. And we don't just stop at open sourcing something. We continue to support and we continue to maintain. If you look at Spark, for example, that project is alive and kicking and thriving. And actually, Databricks, 70% of the support still comes from Databricks today. So what that means for customers is that there is no lock-in. You come onto the platform, we hope that you will stay there forever. But if you, for example, for whatever reason, if you'd like to take your workload away from platform, you're completely free to do that. The workload will still run on your on-prem or wherever you take it, it will still run. We want you to stay, but only because you love the platform and not because of some artificial handcuff. So that is one. Second thing is that Databricks provides you wall-to-wall coverage when it comes to all your data asset, right from ingestion to transformation to storage to governance to building data applications in the form of BI dashboards or ML models to deploy it, to share it. The whole ecosystem, we got it covered. So with one login and one authentication, that's all you need, and you will get to consume all the services that you are authorized for. You do not have to stitch together a multitude of different services for your application stack to work. So that's another differentiator. And the other thing is we are multi-cloud. So there was a survey by a prominent organization, and they say 80% of Fortune 500 companies work at least with 2 clouds. Some of them work with 3 clouds. And the difference at Databricks is that compared to a particular cloud vendor, when you come to Databricks, your data assets can be anywhere, but once you log onto the platform, your user experience, all the platform capabilities, they are the same no matter which cloud your assets are lying, right? And that cannot be said about some of the other cloud native platforms, right? For example, if you take Amazon EMR, they've made so many modifications that your workload that is running on EMR, it's difficult to take out and run it anywhere else. But with Databricks, the portability is given. So those are the 3 things, and there are a lot of other nuances depending on use case, depending on customer preferences. We can dig into those, but these are the 3 high level, industry level differentiator that we have in Databricks platform.
Thanks, Ketan. Appreciate it. This next question, I'm going to direct at Michael. Michael, can your migration accelerator help with a cross-cloud or region-to-region migrations too?
So I think that one's actually for me.
Great question. Yeah, I'll let Shannon take that one. He's got some particular experience in that regard.
Fair enough.
Yeah. So the way we built our UC migration accelerator, yes, first and foremost, going from Hive to Unity Catalog was job number 1. But really early on, we connected with a client who also wanted to migrate from one data center to another. So we did expand our execute scripts to handle this extra case. Great added benefit is it would also work for cross-cloud. So once you've got your Databricks environment and you've got that URI, we can plug that in along with your credentials, and we can help you get across cross-cloud if you'd like.
Understood. Thanks, Shannon. Okay, our next question, and again, I think this is for the Blueprint folks. So this is a tool for data analysis, not systems analysis, is the question.
Yeah, it's a great question. I think it's a little bit of both. So Lakehouse Optimizer, from a systems perspective, is exclusively segmented to observe Databricks as well as the cloud provider and the requisite cloud resources that are needed to run Databricks. So from a infrastructure and systems perspective, it will monitor those components, make sure that things are up, running, and working as well as possible. And from a data perspective, that's where the data and AI governance components come in, like what Shannon was showing in the Unity Catalog assessment component, where that's going to be actually looking at your data and your code and making sure that those things are in a good position to be migrated to Unity Catalog and that they're healthy from an ongoing perspective beyond that migration. So it's a little bit of both.
Understood. Thanks, Michael. Next question, how can organizations prepare their existing data infrastructure for a smooth migration to Unity Catalog?
And that'll be me. First and foremost, take a look at your code complexity. Again, if you've got a lot of bespoke code, it's going to be a little more difficult. Just get a real sense of how involved that connection is between your code and the data itself. Also, if you want to take proactive steps, go ahead and start moving your data from DBFS root onto cloud storage. It can be a mount point. It could be an external location, really whichever you can use in your environment, go that way. Once you've made that switch, you open up a lot more options for you on how you conduct your migration. Anything from sync to CTAS. I mean, it really opens up options once you have your data in cloud storage. And
if I can add a little bit, if I can add a little bit, I think a general rule of thumb is that anytime you're getting ready for a major upgrade or migration, the rule of thumb is try to get rid of your technical debt as much as you can. Right. So take a look at jobs that have not been run in months and years. Take a look at data sets that nobody's touching. Right. Before you enter the migration or upgrade phase, just get rid of them. So that way you're reducing the scope of work and complexity.
That's a good one. Easiest way to migrate is not to migrate it.
That's a great point. Okay, moving on to our next question. And Michael, I think I'm going to start off with you, at least on this question. Data is also known to be versatile. Is it difficult to run third-party software on the platform? For example, I have most of my applications written on SaaS.
Well, I think it seems like a Databricks question, but yeah, Michael, take a shot, and then let's see if.
I'll take it more from a Blueprint application perspective.
Okay.
So there's, I think, probably two parts to this, and without knowing exactly what was being asked here, there's running code on the Databricks platform, and then there's running our assessment module and our tools, et cetera, that work in conjunction with that. So probably a good question to answer is how this thing gets deployed. We essentially provision a virtual machine within your cloud infrastructure, deployed within your private cloud. All of the data that gets generated stays within your walls. You don't have to open up any firewall ports or anything. It's entirely self-contained and enclosed there. And all of the compute needed runs entirely separate from Databricks. So it leverages a host of Databricks APIs to be able to bring that information in, as well as APIs from the cloud provider, does that analysis in near real time, and then spits out those results. So if that answers your question about how we're running our software in conjunction with the platform, hopefully that helps. But Ketan, if you wanted to answer a little bit more about how code is run on Databricks, that might help.
Yeah, sure. Thanks. When I look at the question from Paul Edon, my interpretation of the question was, if you have workload running on SaaS or any other platform, right, how easy or difficult does it make migration? This is not just Unity Catalog or Lakehouse Optimizer question. I think it is migration across the system, if I read the question correctly. And to that extent, we do have other tools and partners that can help you migrate your workload from any system, including SaaS, onto Databricks. And at that point, once you start cracking the big picture, that's when you'll start to worry about how can I optimize and how can I make Unity Catalog compliant. That's where what we just presented comes into play.
Thanks, Ketan. Okay, I think we have time for a few more questions. The next question is, when you say Lakehouse Optimizer works in near real time, what does that mean exactly?
Yeah, that's a great question. So the notion of real time or near real time or just performance as a whole is an interesting question. I think I always like to answer that in the context of how fast does it actually need to be for the intended purpose. So for Lakehouse Optimizer, we wanted to make sure that we could enable two main functions. The first one being, we wanted to ensure that folks didn't need to be staring at another interface, even though we're pretty proud of the way that it looks and feels and works. We wanted to make sure that you could have insights delivered to you wherever you were in a fast enough fashion to be able to take action. So near real time for us means basically from a performance perspective versus a cost perspective. On the performance side of things, millisecond latency as it relates to jobs that are currently being run. On the cost side of things, we're a little bit more hindered there. The cloud provider will throttle a little bit of your ability to get direct numbers from them to be able to see exactly how much any of those interactions cost. We also decided to generate a feature to create estimated costs on the platform. So it tends to run a couple of percentage points off, but allows somebody to, again, I'll say this a little bit cheeky, in near real time, if you are a practitioner that's working on a particular workload, to be able to see as soon as a job is run within a few milliseconds or moments after that job has occurred, what the real cost actually looks like of that. So that's a unique capability of the platform there as well. Additionally, for jobs that are running long, since we're collecting telemetry in that near real-time perspective, again, I'll probably give that the context of high number of seconds, almost up to a low number of minutes. For long-running jobs, if they're trending in a manner that looks like it's going to fail, if they're going to run out of resources, if you have spot instances that are being taken away because you're not bidding high enough, a number of those kind of challenges that can happen for a long-running job, you can take action on those while they occur. So we wanted to make sure that near real-time really incorporated those use cases to be able to support the practitioners.
Got it. Thank you, Michael. I think we have time for one more question. It's from me to all of you. And Caden, why don't we start off with you? If there's one thing you'd really like our attendees today to walk away keeping in mind, what would that be?
All right. So from my perspective, I think if you're a data practitioner, whether you're working with data analysis, whether you're working with data engineering side of it, whether you're working with AI, machine learning, data science type of application, my golden advice will be try to minimize your fragmentation, and that means you come to a platform where you can do it all from one set, from under one roof. You have access to all those capabilities. That way, I think you'll reduce your complexity, and you'll do yourself a favor and make your life simpler. But
Oops, looks like Caden got cut off. Hopefully everyone else can hear me. In any case,
Yeah.
Shannon, why don't we move to you next?
Okay. I would say the number one thing to keep in mind with any data platform, configuration-driven code, metadata-driven code, it simplifies so many things. It reduces total cost of ownership because there's far less code to maintain, but it also allows you to make changes a lot more easily and a lot more efficiently. From moving from Hive Metastore to Unity Catalog, moving data between storage accounts, between clouds, between on-prem and the cloud. It's just the way to go. It makes life so much easier.
Understood. And Michael, anything you'd like to add on?
Yeah, that's a great point. There's always so many things to add. I think the thing that, if I could have you guys pick one item away from this conversation, optimization can be scary, it can be very technical. There can be a lot that goes into it, and there are dozens of different dimensions to look at. There's tooling out there. We're one of many providers that can help. Would love to be able to help you guys on your optimization journey and show you just that it is easier than you expect, and that if you start early, you can have more benefits over time. I know Shannon was mentioning the total cost of ownership components. It's one of those things to, not to be so cheeky about it, but acting now can be a huge benefit for long-term as it relates to allowing your optimization journey to be compounded. So start it early, use great tooling to help you get there, and you can be in a great position really early on in your journey.
Absolutely. Well, I would like to give a huge thank you to our speakers today for coming on board and sharing their insights and expertise. Once again, Michael Hollick, Director of Product Sales at Blueprint, Shannon Lauder, Solution Architect at Blueprint, and Ketan Ganatra, Solution Architect at Databricks. If you in attendance would like to review this presentation or send it to a colleague, you can use the same exact URL that you used for today's live event. It will be archived, and you will receive an email from us once the archive is posted. Also, as I mentioned earlier, just for participating in today's event, you could win this $100 Amazon gift card. The winner will be announced on June 28th. We'll let you know if you're the lucky viewer. Thank you, everyone, for joining us today, and we hope to see you again soon.